somewhere above the roof over your head, past the streetlights and the thin weather and the highest thinning clouds, there is a great wheel of 100 billion suns turning so gradually that no eye could ever catch it moving, and at the very middle of that wheel sits something you will never see and have nothing to fear from at all. It has been there longer than the ground beneath your bed, longer than the oceans, longer than the earth itself. It does not glow. It does not call out. It simply rests at the centre of everything, holding the whole bright spiral steady in the dark, and tonight you're going to drift out toward it and back again, and arrive, by the end, more deeply at ease than when you began. It is darker than the space around it and heavier than 4 million of our suns laid together, and it has been resting there at the heart of this galaxy, ours, the Milky Way, since before the first living thing ever stirred in any sea. It does not reach out for you. It does not pull at the night sky or tug at the ground where you are lying. It simply holds, the way any great mass holds, the way the sun holds the earth through the long arc of a year, the way the earth holds you against the sheets right now, and around it, in long and faithful circles, an entire city of stars goes wheeling through the dark, unhurried, untroubled, exactly as it has for ages beyond counting. This is one of the supermassive black holes, the calm and ancient cores around which entire galaxies are built. And the strangest comfort of them, once you truly understand them, is how perfectly still they are. You do not need to hold any of this. There is nothing here to learn, nothing to memorize, nothing the morning will ask you to recite. Let the facts move through you the way warm water moves over open hands, touching you for a moment, then slipping away, asking nothing in return. Some of these wonders will follow you down into sleep, and some will dissolve before you wake, and either way is exactly right. This is the deep ease of the very large and the very far. It was here long before anyone wondered about it, and it will keep its silence long after, and it asks nothing of you tonight at all. So let the mind go loose. Let the shoulders give up their weight to whatever holds them. Let your eyes close whenever they wish to close. The galaxy is in no hurry, and for these few hours neither are you. Begin close, with a single name. At the centre of the Milky Way, in the direction of the constellation the old stargazers called the Archer, there is a faint source of radio whisper that scientists have named Sagittarius A star, written with a small star beside the letter, like a single point of light pinned to the corner of a page. For decades it was only a hiss in the antennas, a smudge of static drifting up from the galaxy's crowded middle, a signal nobody could quite explain. Now it is understood to be a black hole holding roughly 4 million times the mass of the Sun, packed into a region of space that would fit comfortably inside the orbit of the innermost planet. 4 million suns, folded into a sphere you could tuck inside a single solar system, resting in perfect stillness at the hub of everything you have ever called the sky. Try, for just a breath, to feel the weight of that number. 4 million stars, each one a furnace like our own, all gathered into a single dark and silent point. Every star you have ever wished upon turns in some vast and unfelt way around it. The whole disk of the Milky Way, every star you could ever name, leans on that single dark point at its hub. That hub lies about 26,000 light-years from where you rest, and the number is almost too large to feel, so let it arrive in pieces gently. A light-year is the distance light crosses in a single year, moving at the fastest speed there is, and the galaxy's heart lies 26,000 of those distances away. The light now reaching the great telescopes from that dark centre left it 26,000 years ago, when the last ice age still gripped the north and no city had yet been raised anywhere on Earth. It crossed the empty lanes between the stars the entire time, steady and unbroken, passing through cold nebulae and the glow of newborn suns, while every human story you have ever heard unfolded and ended beneath it. What the astronomers see at the galaxy's heart is not the present at all. It is a message written in old light, set out before the pyramids, before the first written word, before the first sown field, and it has been travelling toward this exact night, toward this exact darkened room, for longer than memory itself can reach. For most of human history, no one suspected anything was there. The centre of the galaxy is hidden behind thick veils of gas and dust, long lanes of darkness that drink up ordinary starlight and let almost nothing through to the eye. Looking toward it with visible light is like trying to read the flame of a candle through a wall of smoke. Only when astronomers learn to gather other kinds of light, radio waves, which slip easily through the dust, and the deep, warm glow of infrared, which the veils cannot stop, did the curtain finally thin and the crowded, blazing core of the Milky Way swam into view, with that one peculiar silence sitting dead in its middle. For thousands of years, people had gazed straight toward it on summer nights, into the brightest part of the Milky Way's pale band arching overhead, and never once known that the heart of everything was hiding just behind the haze. The grandest thing in the sky kept itself veiled in plain sight, waiting through every generation for eyes that could finally see in the colours the dust allows. What gave the silence away was the company it keeps. Right at the galaxy's heart, a small cluster of stars moves in a way that makes no sense at all, unless something enormous and unseen is holding them. They do not trace lazy, open arcs like most stars in the sky. They wheel in tight, swift loops, swinging hard around a single invisible point as though tethered to it by an unbreakable thread. For nearly 30 years, two teams of astronomers track these stars night after night, year after slow year, watching them creep along their orbits the way one watches the hour hand of a clock, too slow to see moving, yet undeniably moved by morning. The shape of those orbits revealed beyond any possible doubt the mass hiding at the focus. You cannot see the thing itself. It gives off no light to see. You can only watch the stars dance around it and read its weight in the steps of the dance. The dark centre never shows its face. It only moves the stars and lets the stars in their long, faithful circling tell the truth. It is a strange and lovely inversion. The most invisible object in the galaxy is found by watching the most visible things obey it. One of those stars has become known. It is called S2, a bright blue sun a little larger and hotter than our own, and it runs the entire length of its orbit around the black hole in about 16 years, a single full circuit, where the Earth, in its easy path around the sun, would need 100 million. At its closest sweep it comes within a distance still vastly greater than our whole solar system, yet near enough that it whips around the turn at a breathtaking pace, racing at nearly 3% of the speed of light before slinging back out into the long cold reaches of its path. As it rounds that closest point, astronomers have even watched its light shift colour slightly, stretched by the deep gravity exactly as the equations of relativity foretold a century ago. Generations of astronomers have now watched it circle that unseen centre more than once, tracing the same great ellipse again and again. And every time it does, it draws, with its own moving body, the precise shape of a mass that no telescope will ever picture directly, writing the black hole's weight across the sky in living starlight. A single star, patiently circling, became the proof. The two scientists who led that long watch, Reinhard Genzel and Andrea Ghez, were given a share of the Nobel Prize in Physics for it, in the autumn of the year 2020. They had not photographed anything. There was nothing to photograph. They had simply followed the stars with extraordinary care for years longer than most discoveries ever take, through countless cold nights at the great mountaintop telescopes, until the motion of those distant suns left only one possible explanation standing. The other half of that same prize went to a mathematician, Roger Penrose, who had shown decades earlier, using nothing but pen and paper and the equations of gravity, that such objects were not a flaw or an accident in the mathematics, but a true and unavoidable feature of the universe. One half of the honour came from looking outward through the cold night air for 30 years. The other came from looking inward at the equations and trusting what they quietly said. Two very different ways of seeing the same dark truth, the watcher and the thinker, rewarded together in the end. At its swiftest, That blue star tears along at thousands of kilometers each second, fast enough to cross the gap between the Earth and the Moon in under a minute. It was the first Nobel ever given for the direct study of a black hole, a reward for 30 winters of cold mountain measurement. There is a habit of mind that imagines these objects as hungry, as great mouths in the dark drinking down everything around them, dragging the heavens toward their throats. The truth is far more restful and worth carrying with you tonight into sleep. A black hole pulls on the things near it no more strongly than any other body of the very same mass would. If the sun were quietly replaced this very moment by a black hole of exactly the sun's weight, the Earth would not be drawn in or disturbed in the slightest degree. It would go on circling in the same orbit at the same speed, through the same unbroken year, in sudden darkness but in perfect mechanical peace. The only change is sky gone dark, the planets wheeling on exactly as before. Gravity does not care whether a mass is bright or dark, enormous or tiny in size, only how much of it there is, and how far away you happen to be standing. From a safe distance, a black hole is simply another anchor in the dark, holding its companions just as it always has, with the same even, indifferent, untiring grip. A black hole is not a vacuum that inhales the heavens. It is only a mass, and mass merely holds whatever circles it. The word that sets these apart from all their smaller cousins is supermassive, and it is not poetry but a precise category. An ordinary black hole, the kind left behind when a single heavy star collapses at the end of its life, weighs only a handful of times more than the Sun, 10 suns, perhaps 30, crushed into something no wider than a town. The supermassive ones begin at 100,000 times the Sun's mass and climb upward from there, through the millions and into the billions, in a leap so vast that the two kinds barely seem to belong to the same family at all. It is the difference between a single grain of sand and an entire mountain range. Both are made of the same stone, obeying the same laws, and yet one is so much larger than the other that the mind can scarcely fold the two into a single thought. These giants are a category unto themselves, the great elders among black holes, and there is one waiting at the centre of nearly every galaxy in the sky. To call one supermassive is simply to say it has crossed that threshold and joined the great quiet company at the hearts of the galaxies. A mountain and a grain of sand are both stone, yet no one would mistake the one for the other. So it is with the small black holes and these vast ones. Hold the very largest of them for a moment, because the number has a strange music to it. Out in a distant quasar that astronomers have labelled TON 618, there sits one of the most massive black holes ever measured, somewhere in the range of tens of billions of solar masses by the most careful estimates. Tens of billions. If our own 4 million sun centre is a single deep note struck low on a piano, this one is the entire bottom of the keyboard pressed down at once, a chord so deep it is felt more than heard. Its edge alone, the boundary from which nothing returns, is so wide that light, the fastest thing there is, would take days to cross from one side of it to the other, and yet it makes no sound, casts no shadow you could ever stand in, and sits so impossibly far away that its danger to you is exactly zero. It is a fact to be marvelled at, never feared, a giant asleep at the bottom of the cosmic sea, dreaming whatever such things dream. Light from that giant set out so long ago that it began its crossing before the Earth had even cooled, and reaches us only as the faintest mote of fire. The edge itself has a name worth knowing softly, the event horizon, the one-way boundary around any black hole, the precise distance at which the pull grows so deep that not even light can climb back out. For these giants, the horizon is enormous. The one at the Milky Way centre could swallow the entire orbit of the smallest planet and still have room to spare. The one in a galaxy called M87, which you will meet again before this night is through, is wide enough to hold our whole solar system, planets and all, comfortably inside its dark rim. These are not pinpricks in space, not tiny lethal points. They are spheres of perfect darkness larger than the paths the planets trace, and they hang in the deep silence between the stars, turning almost imperceptibly, harming nothing for 10,000 light-years in every direction. The edge is vast, and the vastness is exactly what makes it gentle. For these greatest ones, the edge encloses more empty room than the orbits of entire planets, a boundary you could drift across without ever finding a wall. By some estimates, its edge is hundreds of times wider than the whole span of our planetary system, a darkness broader than the orbits of entire worlds. Here is a surprise that quietly loosens the whole idea of them. You might imagine that something so heavy must be unthinkably dense, crushing, like a wall built of collapsed stone. For the very large ones, the opposite turns out to be true. Because the event horizon grows wider faster than the mass within it grows heavier, the average density of a supermassive black hole, its total weight spread evenly across the enormous volume it encloses, can be astonishingly low. A black hole of around 400 million suns would have an average density no greater than ordinary water, the kind that fills a glass on a bedside table. A larger one of some 11 billion suns would be on average thinner than the very air in this room. You could not float in it or breathe it, of course. The figure is a kind of cosmic accounting rather than a place to visit. But it dissolves the image of crushing weight entirely. The biggest of these objects are, by this strange measure, lighter than water. It is one of the quiet jokes the universe keeps, that its very heaviest objects spread across the room they make can be among its most diffuse. Squeeze the sun to that state and its edge would be only a few kilometers wide, but multiply the mass enough and the edge balloons faster than the weight. The colour of them is not really black either, though that is the only word the language gives us. A black hole gives off no light of its own. Nothing shines from within it, because nothing can ever leave, but it is far from invisible. Around many of these centres swirls a great disk of gas and dust drawn into long flattened orbits, and as that material crowds inward it grinds against itself, heats by friction to staggering temperatures, and begins to glow, blue-white, fierce, brilliant beyond any furnace on Earth. The darkness at the very middle is real, a true circle of nothing. But it is so often ringed in fire that what the telescopes actually catch is not a black thing at all. It is a bright thing with a dark heart, a ring of furious light wrapped around a small circle of absolute calm, like a single still eye at the centre of a storm of radiance. What looks black in a child's drawing is, in truth, more often a blaze of colour wrapped around a small dark pupil, like an iris of fire. The colours run from blistering blue at the inner rim to deep ember red farther out, a single great eye of flame staring into the dark. When that ring of light blazes at its very brightest, it earns one of the loveliest names in all of astronomy, a quasar. The word began life as a puzzle. In the early days of radio astronomy, certain points in the sky poured out tremendous energy, and yet looked, through ordinary optical telescopes, like faint and unremarkable stars. So they were called quasi-stellar radio sources, star-like things that were somehow not stars at all. And the long, clumsy phrase was worn down by use into the single bright word quasar. They turned out to be the blazing hearts of distant galaxies, each one lit by gas spiralling down toward a supermassive black hole. The plainest looking pinpricks in the old photographs were among the most powerful engines in the entire universe, hiding in plain sight as humble dots of light. The night sky keeps its grandest secrets, it seems, in its most modest looking corners. A single faint dot, no brighter than 1,000 ordinary stars to the eye, can be the most powerful single object for billions of light years in any direction. The word itself, quasar, is a worn-down fragment of a longer phrase meaning star-like radio source, a name born from how ordinary these blazing giants first appeared. The brightness of a quasar is genuinely difficult to hold in the mind, so let the comparison do the work for you, gently. A single quasar, powered by the matter spiralling into just one of these black holes, can outshine an entire galaxy of 100 billion stars, sometimes by 10 times over, sometimes by 100, in the most brilliant cases by tens of thousands of times. And all of that light pours from a region no larger than our own solar system. Imagine a single lantern the size of a back garden that outshines a whole continent of glittering cities, every one of them combined, and you begin just barely to approach it. These are the most luminous, steady beacons the cosmos contains, yet their light is so far away that to your eye, on the darkest night, even the very brightest of them would be only the faintest possible speck, a whisper of fire that crossed billions of years of empty space to arrive, unhurried at last. The brightest of them shine so steadily that, were one placed where our nearest neighbouring star sits, it would outshine the full moon in our sky. All that brilliance escapes from a space scarcely wider than the planet's paths, a furnace small enough to lose in a corner of a galaxy, yet outshining all its 100 billion stars. The first of these strange beacons ever to be understood sits in a galaxy catalogued long ago as 3C273. For years it was simply a baffling point of light with an impossible energy, until astronomers measured how swiftly it was racing away with the expansion of the universe and realised, with some astonishment, how staggeringly distant it had to be, and therefore how unimaginably bright, to appear at all from so far. It became the first object ever recognised as a quasar, the first time anyone understood that a faint dot in a telescope could be the fiery signature of a black hole feeding 2 billion light-years away. A single point of light in a photographic plate, and behind it, a furnace older and larger than the Earth, blazing across a gulf so wide the mind goes quiet trying to cross it. The discovery rearranged the whole sense of how far and how powerful the universe could be. Before that night, no one had imagined a single point of light could be a galaxy's blazing heart, seen from across the better part of the visible universe. That single discovery stretched the known scale of the cosmos almost overnight, revealing that a faint speck could blaze across nearly the whole observable universe. There is a deep and lovely riddle folded into these most distant quasars, one that astronomers are still turning over gently in their hands. The light from the farthest of them set out so long ago that we see them as they were within the first billion years after the universe began, and even then, so impossibly early, they were already powered by black holes of 1 billion suns or more. They had somehow grown enormous almost at the very dawn of everything, far faster than seemed possible from the slow gathering of gas alone. How they managed it remains an open question, a soft mystery written in the oldest light there is. Some answers may take a lifetime of careful work to arrive, and there is no need at all to solve it tonight. It is enough to know that the universe very early on was already quietly building these vast and calm anchors, and has been holding its galaxies steady around them ever since. The newest telescopes keep finding them earlier and earlier, deeper into the dawn of time, each discovery gently widening the lovely puzzle rather than closing it. For all the centuries that people wondered about such things, no one had ever actually seen one. Not directly, not the dark heart itself. That changed on a spring day in the year 2019, when astronomers unveiled the first true image of a black hole. It was not the one at our own galaxy's centre, but a far larger giant, the one in that galaxy called M87, some 55 million light-years away. The picture showed exactly what the physics had long foretold: a ring of warm orange light, a little brighter along one edge, wrapped around a round pool of perfect darkness. The shadow of the unseeable made visible at last. After all of human history spent looking up and wondering, our species had for the first time looked a black hole directly in the eye, and found, at the centre of all that fierce light, only a calm and silent circle of dark. The image travelled for 55 million years to reach us, set out when the dinosaurs had only recently vanished from the Earth, and arrived to be seen in a single human morning. The ring it revealed matched what the theory of gravity had foretold more than a century earlier, one more confirmation of an old idea under the most extreme conditions there are. It was unveiled to the world all at once, in 6 press conferences across the globe, the first time our species had ever looked upon such a thing. Making that single image asked something almost absurd of the people who built it. No telescope on Earth is remotely large enough to resolve so small and distant a shadow on its own. So astronomers linked together radio dishes scattered across the entire face of the planet, from the volcanoes of Hawaii to the deserts of Spain to the ice of the South Pole, and combined their measurements into one virtual instrument as wide as the Earth itself. They called it the Event Horizon Telescope. For a few precious nights, the whole spinning world became in effect a single eye, gathering faint radio light from a ring of fire 2,000 trillion miles away. The photograph that resulted came not from one machine in one place, but from a planet acting in quiet concert, its observatories turned together toward the same far dark. It took the cooperation of the entire Earth to capture the shadow of a single distant heart. Each dish recorded its faint sliver of radio light onto stacks of hard drives so vast they had to be flown, physically, across the world to be combined into one picture. Turning that flood of raw signal into a single image took teams of scientists the better part of 2 years of careful work. The data filled half a ton of hard drives, far too much to send by any wire, so the disks themselves were flown by plane from pole to pole. The giant they pictured holds about 6.5 billion times the Sun's mass, more than 1,000 times heavier than the dark centre of our own galaxy. Its event horizon is so vast that our entire solar system, with all its planets, and the long cold orbits of the comets beyond them, would fit comfortably inside with great room to spare. And yet, from 55 million light-years away, it appeared no larger in the sky than a small coin would, were that coin set down on the surface of the moon and viewed from your own back garden. To see something so faint and so fine was very much like reading the date stamped on that distant coin from here on Earth. The sheer patience and precision of it is its own kind of marvel, a thing more delicate in its way than the immense and silent object it finally revealed. To resolve a shadow that's small and that far is the equivalent of standing in one city and reading a newspaper held open in another, across an ocean. That same galaxy holds another wonder, one noticed long before anyone knew what could possibly lay at its core. Reaching out from the centre of M87 is a thin, straight beam of light, a brilliant jet of glowing matter flung far outward across the dark. An astronomer first recorded it more than a century ago, in the year 1918, describing only a curious straight ray emerging from the galaxy's middle, with no idea on Earth what could produce such a thing. That ray is now understood to be a jet streaming from the black hole's immediate surroundings, and it stretches an astonishing 5,000 light-years out into space, a single shaft of light longer than the distance separating thousands upon thousands of neighbouring stars. For 100 years it was simply a beautiful mystery in a photograph. Now it is known to be one of the grandest fountains the universe makes. The jet glows in every kind of light, from radio to X-ray, a single thread of brilliance longer than the gap between thousands of stars, flung perfectly straight into the dark. It glows across every kind of light there is, from radio waves to X-rays, holding its arrow-straight shape across a span longer than thousands of neighbouring suns. These jets are among the most dramatic things the black holes ever do, and yet there is nothing frightening in them once you understand their shape. As gas spirals inward, twisting magnetic fields wind tighter and tighter around the spinning centre, and some of that in falling matter is hurled away again before it ever crosses the edge, flung outward along the black hole's axis of spin in two narrow beams, one streaming from each pole travelling at very nearly the speed of light. They are like fountains aimed straight up from the top and bottom of a slowly turning sphere, throwing brilliant streams thousands of light-years out into the surrounding dark. It is not a swallowing at all, but a spilling, a giving back. The black hole returns energy to its galaxy nearly as fiercely as it draws matter in, breathing out as much as it takes, a great two-way exchange written across the void in light. A black hole, for all its dark reputation, may return to its galaxy nearly as much energy as it ever takes in, breathing the cosmos out as well as drawing it close. And those jets do something quietly profound to the very galaxy that holds them. When they blaze out at full power, They heat and push the surrounding gas, sweeping it outward in great tides, stirring it so thoroughly that it can no longer cool and gather and settle into new stars. A galaxy makes its stars by letting cold gas collapse under its own weight. A black hole, simply by warming and scattering that gas, can gently switch the whole process off. So these central engines act as a kind of patient regulator on the vast city of stars around them, deciding, across hundreds of millions of years, how many new suns their galaxy is permitted to light. The smallest object at the very centre governs the fate of the largest structure around it, a single dark point, no wider than a solar system, steering the destiny of 100 billion stars. There is a strange and tender order in that. The galaxy's whole future supply of new stars rests in part on the moods of the small dark engine turning at its core. Switch the engine off, and the gas cools and gathers into new suns. Let it blaze, and the gas scatters, and the galaxy's star-making falls still. This is perhaps the most beautiful turn in the whole story. The black hole and the galaxy seem to have grown up together, like two things raised side by side. For all their staggering difference in size, the mass of the central black hole tracks, with surprising faithfulness, the size and the swarming motion of the dense bulge of stars at the galaxy's core. A bigger bulge means a bigger black hole in a ratio so steady and so repeated across so many different galaxies that it simply cannot be a coincidence. Astronomers call it the M-sigma relation, after the symbols in its equation. What it whispers is that the heart and the body of a galaxy shaped one another over billions of years, each holding the other in check, growing in careful step, like two notes that learn to stay in tune across the entire age of the universe. The centre and the whole, rising together, keeping time. Measure the speed of the stars swarming at a galaxy's heart, and you can guess the weight of the unseen giant within. The two so tightly bound they rise and fall as one. The relationship is so reliable that it holds across galaxies of wildly different shapes and ages, a single thread of order running through them all. The faithfulness of that relationship is what makes it so striking to those who study it. Galaxies collide, merge, and swallow one another whole over cosmic time. Gas pours inward in great floods and is blown out again in storms. By every reasonable expectation, such upheaval should long ago have scrambled any simple connection between the black hole and its host galaxy. And yet the ratio holds, again and again, galaxy after galaxy. Something keeps gently correcting it, nudging the two back toward balance whenever they begin to drift apart. Most likely the very feedback of those heating jets, which slow the black hole's own feeding at the same moment they slow the galaxy's star-making. A self-steadying system, written across millions of light years, keeping its quiet equilibrium through every collision and every storm. The cosmos, it turns out, is deeply fond of balance, and finds its way back to it even after the wildest upheavals. Whatever scrambles the balance, something steadily restores it, again and again, across spans of time that make the age of the Earth seem a passing afternoon. No collision, no flood of gas, no upheaval seems able to break the bond for long. The two always find their balance again. The likely peacemaker is the feedback of the jets themselves, which slow the black hole and the galaxy together whenever either races ahead. Knowing that steady ratio gives astronomers a kind of cosmic measuring tape. Because the black hole's mass tracks the motion of the stars in the galaxy's bulge, they can simply watch how quickly those stars are swarming about the centre, a speed they can measure even in galaxies far too distant to study in any other detail, and from that alone estimate the mass of the hidden giant lying within. A whole population of unseen black holes, weighed from clear across the universe, simply by reading the dance of the stars that surround each one. It is the very same trick first practiced at the heart of our own galaxy, scaled up now to galaxies beyond all counting, never once seeing the thing itself, only the motion it commands, and trusting that motion faithfully to tell the truth. The dark stays dark, and the stars do the telling everywhere at once. In this way, the heaviest hidden things in the universe are weighed not by touching them, but simply by watching, patiently, how the bright things near them move. So nearly every great galaxy, it turns out, keeps one of these at its very heart. Wherever astronomers look, at graceful spirals like our own, at the vast elliptical clouds of older stars, at the bright distant cores of galaxies billions of light years off, they find the unmistakable signs of a supermassive black hole anchoring the middle. They appear to be a standard feature of how large galaxies are built, as ordinary in their way as a stone resting at the bottom of a well. The night sky is quietly full of them, one to a galaxy, uncountable thousands upon thousands upon thousands of calm, dark centres, each holding its own slow wheel of stars in the deep and patient dark. To look up at any galaxy at all is to look toward one of these silent hearts, hidden somewhere in its glow, holding the whole of it together. Look toward any distant smudge of a galaxy on a clear night, and somewhere within that faint glow a dark centre is faithfully keeping all of it in order. 3 years after the picture of M87, in the spring of the year 2022, that same worldwide telescope turned its gaze inward toward home and gave us the first image of our own. There, at the very heart of the Milky Way, was Sagittarius A star at last made visible, a smaller, more delicate ring of light around its own circle of dark, the very object whose weight had been read for decades only in the motion of the stars. After all those years of patiently watching suns swing around an invisible point, astronomers could finally see the point itself, or rather, the bright warm halo drawn around its shadow, the heart of our own galaxy, photographed from inside it, 26,000 light-years deep through all that dust and distance. The hidden centre of home, looked upon directly for the very first time in the long history of the world. For every person who ever lived and wondered about the sky, that dark heart was always there, exactly so, and only now has anyone living finally seen its ring of light. Our own central black hole turns out to be a remarkably calm and gentle one. It is not feeding heavily at all, only a thin trickle of gas drifts toward it, so it does not blaze as a brilliant quasar or fling out the great luminous jets that some of its cousins do. It rests instead in a kind of long quiescence, an almost sleeping state, sipping rather than devouring. Were it gorging itself the way the young quasars once did, the centre of the night sky might glow with a strange steady fire visible right across the galaxy, and our nights would be different. Instead, it keeps its silence, a dark and patient presence that has held its place through every age of the Earth, through every ice age and every empire and every life ever lived, without once disturbing the small bright world that turns so very far out along the galaxy's quiet edge. It is, by temperament, a sleeping thing, and our nights are gentle precisely because the heart of our galaxy chose long ago to rest rather than to blaze. A trickle of gas drifts toward it, where a torrent once might have, and so our skies stay dark and even, lit only by the ordinary stars. At the very centre of any black hole, the mathematics points towards something the mind cannot quite picture, a place where matter is compressed beyond all limit, where the familiar rules of space and time seem to fold over on themselves and the equations grow silent. Astronomers call it the singularity, and the honest truth is that no one yet knows what truly happens there, sealed away as it is behind the event horizon, where no light and no signal can ever carry word back out to us. It is one of the genuine open unknowns of physics, a locked room at the bottom of every black hole. There is something restful in that rather than troubling, a gentle reminder that the universe still keeps a few of its very deepest secrets entirely to itself, and feels no need at all to explain them to anyone. Some doors are simply meant to stay closed, and that is its own kind of peace. Whatever waits at the centre, it stays sealed forever from the world outside, touching nothing, reaching nowhere, a secret the universe keeps to itself. It is one of the true unsolved riddles of physics, a sealed chamber at the very floor of every black hole, sending no signal whatsoever to the world beyond its edge. What protects the entire rest of the cosmos from that strangeness is the horizon, which seals it away completely and forever. Whatever unimaginable thing the centre may be, it sends no signal outward, exerts no special reach, changes nothing in the world beyond its edge except through the plain and ordinary pull of its mass. Seen from outside, a black hole is almost shockingly simple. It can be fully and completely described by just a few numbers: how much it weighs, how fast it spins, and a faint electric charge it almost never carries at all. Everything else about whatever happened to fall in, every star, every cloud, every fine detail of its long and varied history, is hidden away behind the edge, leaving only that small handful of plain quantities. The most complex deaths in all the universe end in the simplest possible objects. Out of the greatest chaos, the cleanest calm. A whole collapsing star with all its fire and history and turbulence becomes in the end a thing describable in a single short line of arithmetic. That simplicity has a playful name among the physicists who study these things. They like to say that a black hole has no hair. What the phrase means is that two black holes of the same mass and the same spin are utterly identical, no matter what went into making either of them. One built from 100 collapsed stars and another from a great cloud of swallowed gas would be completely indistinguishable, smooth and featureless and exactly the same. Nothing sticks out, nothing whatsoever distinguishes one from another but those few clean numbers. In a universe of endless, restless variety, where no two snowflakes or fingerprints or grains of sand or galaxies are ever quite alike, these stand as the great and singular exception. Perfectly plain, perfectly smooth, as alike as two identical notes struck on the same taut string. There is a deep serenity in that perfect sameness. Two black holes of equal weight and spin are as identical as two notes of the same pitch, no matter the wildly different stories that first made them. One built from 100 fallen stars and another grown from swallowed gas would be flawlessly indistinguishable, smooth as two notes of the same pitch. Many of these giants are also spinning, and spinning remarkably fast. As gas falls inward over billions of years, it tends to arrive turning all the same way, and over the ages it spins the black hole up like a great flywheel steadily gathering speed. The largest of them can rotate so quickly that their outer edge whirls around at a sizable fraction of the speed of light, and as they turn, they drag the very fabric of space around with them, twisting the nearby dark into a slow, deep whirlpool. It is a strange and stately kind of motion, a sphere of pure darkness wheeling silently in place, winding space itself around it like a thread on a spindle, unhurried and immense and utterly without sound. Picture it turning out there now, in the deep between the stars, smooth as oil, patient as stone, a great dark top that has been spinning since before the Earth was born. The fastest of them whirl their edge around at close to the speed of light, dragging the nearby dark along like cream stirred through coffee. This dragging of space itself helps fling the great jets outward and shapes the lopsided glow the cameras catch around the edge. That spinning gives the brightest of them their jets, and shapes the glow around them into something the cameras can finally read. Just outside the horizon, light itself can be bent into orbit, circling the black hole again and again before either falling in or escaping outward into the night. This creates a thin, bright circle in the images, a halo that astronomers call the photon ring, woven entirely from light that looped around the darkness several times over before slipping free toward the distant telescopes. Part of what you see in those now famous pictures is light that very nearly did not escape at all, that travelled the long way around the edge before finally winning free toward home. A delicate ring spun from rays that almost stayed forever, and chose, at the very last possible moment, to leave. The light that lingered longest is the light that drew the brightest circle. Some of the glow in those famous pictures is light that nearly fell in forever, circling the dark several times over, before slipping free toward home at the last. That thin, bright halo in the famous images is woven from rays that looped the dark several times before escaping, the very light that lingered longest. There is a strange softness in how these objects treat time, and for the great ones it is far gentler than you might ever fear. Near a powerful gravity, time itself runs more leisurely, so a clock placed close to the horizon ticks more slowly than a clock far away. But for the supermassive black holes, that change is spread across such an enormous region of space that nothing about it is ever sudden or sharp. You could draw quite near the edge of one of these giants and feel nothing wrong at all. No crushing, no tearing, no warning, while the distant universe behind you simply seemed to run a little faster, the far stars wheeling on at their own quickened pace. The largest black holes are, in this sense, the most forgiving things the cosmos makes. Their sheer vastness is exactly what makes their edges so mild and their welcome so quiet. Where a small black hole would be sharp and unforgiving, a giant one greets whatever nears it with the same indifferent gentleness it shows the empty space around it. This is the great difference between a small black hole and an enormous one, and it overturns the usual fear almost entirely. Near a small black hole, the pull at your feet would be so much stronger than the pull at your head that you would be stretched thin long before ever reaching the edge. But near one of these giants, because the horizon lies so very far from the centre, the pull changes so gradually from one point to the next that the difference is barely there at all. You could cross the edge of a supermassive black hole and feel nothing whatsoever in the crossing. No jolt, no boundary, no membrane, only the same dark you had already been drifting through. The most absolute threshold in the entire universe, for the largest of them, would announce itself with nothing at all. Bigger means gentler, here, in a way that runs against every instinct we carry. And once you know it, the whole idea grows calm. The most absolute boundary in all of nature, for the largest of these, would feel like nothing at all to cross, no more than passing from one dark room into the next. So the very thing that makes them sound the most frightening, their enormous size, is exactly the thing that makes their edges so mild. A grain-sized black hole would be ferocious to approach, sharp and merciless. A giant one of billions of suns would let you drift across its boundary as smoothly as crossing from one darkened room into the next. The danger, such as it is, lives only in the small ones, the sharp ones, and even those sit whole lifetimes upon lifetimes away from anything you have ever touched or ever will. The great calm cores at the centres of galaxies are not knives waiting in the dark. They are wide, deep, forgiving things, and the more enormous they grow, the more gently they hold whatever drifts near. The biggest objects the universe builds are, against all expectation, among the softest at the edge. Size, which sounds like the most fearsome thing about them, is in truth the very thing that makes the great ones so mild and so quiet to approach. It is the small, sharp black holes that would be merciless. The giants greet whatever nears with the same indifference they show the empty dark. How these giants grew so large is a story told across truly unimaginable stretches of time, and it is, above all, a story of patience. Over billions of years, gas drifted inward toward the galactic centre and was drawn in, a little at a time, adding mass across spans that dwarfed the entire age of the Earth many times over. There was no single great feast, no sudden gorging, only a long, unhurried accumulation, gas clouds settling, stars wandering too near, the slow, endless work of gravity collecting matter across the ages. The largest objects in the whole universe were assembled the very way a stalactite forms in a cave, one slow, mineral drop at a time, over a depth of time so vast the mind can hold it only as a word, never as a feeling. Greatness, here, was simply patience given long enough to work, the deep reward of waiting. There was never a single great feast, only the steady drip of ages, gas drawn inward grain by grain, until a giant had assembled itself in the dark. The largest objects in all the universe were built the way a cave grows its stone, one mineral drop at a time, across a depth of ages the mind can barely name. But there is a second way these centres grow, and it is grander still. When two galaxies drift together and merge, as galaxies often do across cosmic time, folding slowly into one another in silent collisions that take hundreds of millions of years to complete, their two central black holes are carried gradually toward the new shared centre. There they begin to circle one another, drawing closer and closer over long ages, until at last they join into a single, greater black hole. These are not crashes in any violent sense at all. The individual stars themselves almost never strike each other, the spaces between them being so unimaginably immense. It is far more like two slow whirlpools merging into one larger calm, two dark hearts becoming a single deeper one at the centre of a single greater galaxy. Even the joining of giants, it turns out, happens gently and takes its unhurried time. The stars of the two galaxies sail right past one another, almost never touching, while far below them the two dark hearts drift together over an age. When two of these giants finally do merge, they send out a tremor through the very fabric of space itself. The joining of two black holes shakes space-time the way a struck bell shakes the air, sending ripples, gravitational waves, spreading outward across the universe at the speed of light. For the supermassive ones, these waves are so vast and so unhurried that a single ripple can take years to wash past. Astronomers have begun to listen for them by watching the steady metronomic ticking of distant dead stars scattered across the sky, searching for the faint synchronized sway that a passing wave would gently cause. In the year 2023, they reported the first signs of a great low hum filling all of space, the combined murmur of countless supermassive black holes circling and merging across the universe, a sound far too deep and too slow for any ear, felt only in the trembling of space itself. The whole of space hums, ever so faintly, with the merging of giants in galaxies beyond counting, a chord too deep and too slow for any creature to ever hear. Astronomers caught its first faint signature by watching the steady ticking of dead stars across the sky sway ever so slightly in unison. That low cosmic hum is, in a sense, the heartbeat of all the merging giants at once, a background thrum woven together from pairs of black holes, spiralling toward one another in galaxies beyond all counting, each pair adding its own deep note to a single chord that fills the entirety of space. It is the quietest music imaginable, stretched across years and across light years, and the universe has apparently been humming it the whole time, unnoticed beneath everything else. There is a profound restfulness in that one image, not a silent and empty cosmos at all, but one filled edge to edge with a single tone too low for any ear to catch, the patient song of dark hearts drawing slowly together over the ages. You're resting right now inside that vast unheard music, as you have your entire life, a lullaby older than the earth, playing on. You've been resting inside that unheard music your entire life, a tone too low to catch, woven through every quiet night you have ever known. Each of these black holes commands a region of space entirely its own, a zone where its gravity rules over everything else. Astronomers call it the sphere of influence. Within that sphere, stars orbit the black hole directly, bound to it just as the planets are bound to the sun. Beyond it, the broader pull of the whole galaxy quietly takes over, and the black hole's particular grip fades into the general weight of 100 billion stars. For our own central giant, that sphere reaches only a few light years across, a small kingdom at the very centre of a galaxy 100,000 light years wide. Inside it, a mere handful of stars belong to the black hole alone. Outside it, they belong to the galaxy. The dark centre rules a modest realm, and rules it absolutely, and reaches not one step further than that. Its power is total, and its territory is small, and beyond its little border, the galaxy goes on untouched. Within a few light years it rules absolutely. One step beyond, and the wider galaxy simply takes over, the black hole's grip fading gently into the crowd of stars. Step back far enough, and the great loneliness of these objects becomes its own kind of peace. A supermassive black hole sits at the still point of a galaxy, that may stretch 100,000 light-years from rim to glowing rim, and for nearly all of that immense expanse, its presence is felt only as a faint and distant anchor. The Sun, far out in the galaxy's quiet suburbs, feels the central black hole only as a small contribution to the great collective pull that keeps the whole pinwheel slowly turning. From here, it is not a looming thing at all, but a far and silent hub, 26,000 light-years away, around which the entire grand carousel of stars, including this one, including the Earth, including you, turns once every 200 million years or so. You are, at this very moment, riding that immense, unhurried circle, and have been riding it your whole life, without ever feeling the faintest motion. The grandest voyage you will ever take is one you cannot feel at all, a smooth, wide circle around a distant dark centre, carrying you softly through the night. Some of these centres send a jet pointed almost directly toward us, and when they do, they earn their own peculiar name. A black hole's twin jets fire outward along its axis of spin, and if that axis happens by pure chance to aim one beam toward the Earth, the galaxy appears especially brilliant and strangely flickering, a kind of quasar seen straight down the barrel of its own light. Astronomers call these blazers. There is nothing at all to fear in the aim. The beam is utterly harmless across such distances, only a thread of light that travelled across billions of years and an ocean of dark to arrive as a faint point in a telescope. It simply means that, by the chance orientation of a distant spinning thing, we happen to be looking straight along the line of one of the universe's great fountains, watching it pour its light directly toward us from the far side of time. A coincidence of angle, nothing more, and a beautiful one. By pure luck of orientation, we sometimes look straight down the throat of one of these great fountains of light, watching it shine directly toward us from across time. These are the blazers, and their aim is harmless across such distance, only a coincidence of angle turned into a steady point of light. Not all of these giants are unthinkably distant either. One of the nearer great galaxies, called Centaurus A, holds a central black hole of some tens of millions of suns, close enough that its jets and the dramatic dark lane of dust drawn across its bright face can be studied in fine detail. It lies only some 12 million light-years away, practically a near neighbour by the generous reckoning of the cosmos, and it has become a favourite window onto how these central engines truly work. Even our nearest large galactic companion, the great spiral of Andromeda, the one faint smudge you can almost see with the naked eye on a dark night, carries at its own heart a black hole far heavier than ours, something like 100 million suns. The night sky's most familiar neighbours all keep these dark centres, each one holding its own galaxy together, and each as harmless to us as a stone resting on a distant shore. Even the night sky's nearest great neighbours carry these dark centres within them, each one anchoring its galaxy, each one utterly safe across the gulf between. Even the great spiral of Andromeda, the one neighbour faintly visible to the naked eye, cradles a dark heart far heavier than our own. Measuring the weight of a black hole millions of light-years away sounds at first completely impossible, and yet astronomers have found ingenious ways to do exactly that. One of the most elegant is simply to watch how the bright gas swirling around the centre flickers over time. When the innermost glow brightens, the gas farther out brightens too, but always a little later, after the light has had time to cross the gap between them. By carefully timing that delay, astronomers can measure the true distance across the glowing region, and from the speed of the swirling gas they can then read the mass of the black hole sitting at its centre. It is a kind of cosmic echo sounding, very much like calling out into a deep canyon and learning its depth from how long the echo takes to return. Light becomes a measuring line, and the delay itself reveals the weight of something no eye will ever see. Light itself becomes the measuring line, and the patient delay between near glow and far glow hands over the mass of an invisible giant. When the inner glow brightens, the outer glow follows a beat later, and that small delay measures the gap, the way an echo measures the depth of a canyon. The quasars, those brilliant feeding beacons were far more common long ago than they are anywhere in the universe today. When astronomers look out to great distances, which always means looking far back in time since the light is old, they find that the universe was once thick with blazing quasars, in a young age when galaxies were rich and overflowing with the cold gas that fed their central black holes. Nearby, in the present-day cosmos around us, the great beacons have largely gone quiet. The gas has been used up or swept away, and the black holes have settled into the long calm that our own now keeps so faithfully. The fireworks of the young universe have faded into the deep stillness of its maturity. The cosmos was once ablaze with these distant lanterns, and has since dimmed gently into rest, much the way a long and brilliant day eases at last toward a quiet evening. The young cosmos blazed with quasars from edge to edge. The present one has largely hushed, its great beacons banked low, settling into the long calm we live in now. The young cosmos blazed with these beacons from edge to edge. Ours has largely hushed, its great lanterns banked low. Much of what these centres give off when they feed is light the human eye can never catch at all. A fierce glow in X-rays, far beyond the colours of any rainbow. Great telescopes that orbit high above the Earth, lifted clear of the air that would otherwise block such light. Watch the hot gas near these black holes shine in that invisible register, mapping the warmth of matter just before it nears the edge. So a black hole that looks utterly dark to ordinary eyes can blaze brilliantly in this hidden light, lighting up the patient detectors of instruments built precisely to see it. The universe, it turns out, glows in many colours we were simply never born to perceive, and these dark centres shine most fiercely of all in the ones we cannot see, singing in a register the eye will never know, faithfully caught by waiting machines. Orbiting observatories, lifted clear above the air that would block such rays, watch these dark centres blaze in light no living eye has ever seen. Telescopes flown high above the air, which would otherwise swallow such rays, catch these dark centres shining fiercely in colours we were never born to perceive. The gas near the very edge can be heated to millions of degrees before it nears the brink, glowing in rays far beyond the reddest red the eye can hold. There is a quiet truth folded into the great distance of these objects. You never see one as it truly is in the present moment, but only as it was when its light first set out. The glow of our own galaxy's centre is 26,000 years old by the time it arrives. The light of a distant quasar may be billions of years old before it reaches a telescope. To gaze toward any of these centres is therefore to gaze gently into the past, to see a thing not as it is now, but as it once was long ago, when its light began the long crossing toward this night. The whole sky shares in this soft delay, every star a small piece of history, and there is a strange peace in it. Nothing out there can ever reach you as it is now, only as it gently was, already softened by the long, patient travel of its light. To look toward any of them is to look into the past, every star and quasar a small fragment of history, arriving long after the moment its light first left. By the time our own galaxy's heart shows itself to a telescope, its glow has been crossing the dark for 260 centuries. A distant quasar's light is older yet. Add up every supermassive black hole in an entire galaxy, and the total is still only the faintest sliver of the whole. Our own galaxy's central giant, for all its 4 million suns of mass, amounts to far less than 1,000th of the mass of the Milky Way around it, a single dark seed at the centre of an immense and turning fruit. The stars, the gas, the great unseen halo of dark matter altogether far outweigh the black hole at the core. So even the grandest of these centres is in the end a small and quiet thing held within something far larger than itself, anchoring the galaxy, shaping it, steadying it, yet never truly dominating its great weight. The heart is small, and the body is vast, and somehow the small, still steady heart helps hold the whole vast body gently together through all the ages. A galaxy's central giant is far less than 1,000th of its whole weight, a single dark seed at the heart of an immense and turning fruit. For all its 4 million suns, our central giant is less than 1,000th the weight of the galaxy it anchors, a small dark seed at the core of an enormous wheel. Of all the things the night sky holds, these may be the steadiest companions of all. A star burns and changes and one day dies. A planet drifts and wobbles in its path. Even the constellations slowly rearrange themselves across the ages. But the great dark centre of a galaxy simply holds and goes on holding, anchoring its 100 billion suns through every change around it. For spans of time the mind can only gesture toward. It was there before the first life stirred on Earth. It is there now above your quiet room, and it will be there long after, turning slowly in the dark. There is a deep reassurance in a presence that constant, that patient, that wholly unbothered by the small and passing weather of the world below. Whatever else moves and fades, the heart of the galaxy keeps its place, and keeps its calm and asks for nothing in return. The light streaming from a feeding black hole carries the temperature of its surroundings written into its very colour, the way iron glowing in a forge tells you its heat. The gas spiralling inward is warmed by friction to millions of degrees as it crowds together near the edge, and at those temperatures it shines not in soft warm reds, but in fierce blue-white, and even in invisible X-rays, a glow far hotter than the surface of any ordinary star. The innermost ring blazes the hottest and the bluest of all. The outer reaches, cooler by far, glow toward orange and deep ember red. So a feeding black hole wears a whole gradient of colour, like a sunset turned somehow inside out, fiercest and palest at its very centre, deepening to warm ember tones at the distant rim, all of it wheeling endlessly, silently, around the small circle of perfect dark at the heart of it. The gas can reach millions of degrees as it crowds inward, glowing hotter than any star's surface, a furnace ring with a still dark pupil at its centre. The sheer scale of the very largest is worth resting inside for a breath, because it stretches the imagination kindly rather than fearfully. The event horizon of that great giant in TON 618 is so wide that our entire solar system, the Sun, all of its planets, and the vast cold reaches where the distant comets drift, would be lost inside it like a single grain of sand dropped into a cathedral. Light itself, crossing the full width of that horizon, would take the better part of a week to make the journey from one side to the other. And yet this colossus is so utterly distant, and so completely indifferent to anything beyond its own small neighbourhood, that it has no more bearing on your night than a mountain standing on the far side of the moon. It is simply there, vast and serene and silent, one more wonder the universe holds and never mentions. Across the full width of that giant's edge, a beam of light would travel for days, and still it sits so far away that it touches your night not at all. Light would need the better part of a week to cross from one side of its edge to the other, and still it changes nothing in the air above your bed. These objects bend the very paths of light around them, and the effect is one of the strangest beauties in all of nature. Because gravity curves the space near a great mass, the light from stars and galaxies passing behind a black hole is bent as it travels by, so that the things lying behind it appear warped, smeared, sometimes doubled, sometimes drawn out into long glowing arcs across the sky. A bright source positioned directly behind one can be stretched into a perfect circle of light, a luminous ring drawn around the central darkness by the bending of the rays themselves. Astronomers named such a ring after the man who first predicted that gravity would bend light at all. The black hole becomes, in effect, a kind of great lens, gathering the light of whatever lies far beyond it, and folding that light into rings and arcs, painting the deep sky with the warped shapes of distant things. A galaxy lying directly behind one can be smeared into a glowing ring or a pair of bright arcs, its light bent gracefully around the unseen mass between. A bright source set exactly behind one can be drawn out into a complete circle of light, named long ago for the physicist who first foretold that gravity bends the path of a ray. When films and artists picture a black hole as a dark sphere wrapped in a glowing band that arcs improbably over and under it, they are not inventing the image at all. They are showing real physics, faithfully. The band beneath the black hole appears to lift up and over the top because the light from the far side of the disk is bent around the sphere and delivered to the eye from above and below at the very same time. The picture astronomers actually made of M87 confirmed it beautifully. A lopsided ring, noticeably brighter on the side where the spinning gas rushes toward us, exactly as the equations had long foretold. Some of the most surreal images ever rendered by an artist turn out to be honest portraits of how light truly moves around these centres. The universe, it gently reminds us, is stranger and more graceful than even the imagination had dared to guess. The strangest pictures the artists ever drew turned out to be honest portraits. The disk's far edge bent up and over the sphere, so that its glow seems to wrap clear around the top and bottom of the dark. The picture of M87 confirmed it exactly. A lopsided ring, brighter on the side where the whirling gas rushes toward us, just as the equations had promised. The dark circle at the heart of those famous pictures is actually larger than the black hole itself, and the reason is quietly elegant. Because light bends so very sharply near the edge, the shadow we see is swollen, magnified by the very gravity that casts it, to something like 2.5 times the true width of the horizon. The black hole projects a shadow bigger than its own body, the way a small object held close to a lamp throws a great wide shape upon the far wall. So even the darkness in those images is partly an illusion of bending light, an enlarged silhouette of a thing far smaller and far stranger than the shadow it casts before it. What looks to the eye like the pure void itself is really the void seen through a lens of its own quiet making, darkness, magnified by its own deep gravity. The void you see is swollen larger than the true edge, an enlarged silhouette thrown by the bending of the very light that outlines it. Between the small black holes and the truly supermassive ones lies a strange and sparsely populated middle ground. Black holes of a few tens of suns are common throughout the galaxy. Black holes of many millions or billions sit anchored at galactic centres. But black holes of only a few thousand or a few 100,000 suns, the in-between sizes, have proven oddly difficult to find. Astronomers call these the intermediate mass black holes, and they may well be the missing link, the very seeds from which the great giants slowly grew, hidden away in the cores of small galaxies or the dense ancient hearts of old star clusters. The patient hunt for them is one of the quiet ongoing searches in all of astronomy. Somewhere out there, the universe almost certainly keeps a whole population of these middle-sized dark hearts, waiting in the gaps between the well-charted extremes not yet found. Somewhere out there, in the cores of small galaxies and old star clusters, the middle-sized ones are surely waiting, the quiet missing rungs of a long ladder. Black holes of a few dozen suns are common, and those of millions sit at galactic centres, but the in-between sizes have proven oddly hard to find. The newest of the great telescopes, peering deeper into the early universe than any instrument before it, has lately deepened the lovely puzzle of how the giants first came to be. It has found supermassive black holes already grown enormous when the entire cosmos was only a few 100 million years old. Startlingly heavy, startlingly soon, in some cases seeming almost too large for the young galaxies that cradle them. It hints that some of these objects may not have grown gradually from small beginnings at all, but formed already massive, springing from the direct collapse of vast clouds of primordial gas in the universe's very first chapters. The whole story is still being written, in light that has travelled for more than 13 billion years to reach the new mirrors. There is something deeply restful in a mystery this old and this gentle, still slowly unfolding, asking nothing of anyone but a little patience. Light that left those infant giants more than 13 billion years ago is only now reaching the newest mirrors, carrying news of a cosmos barely begun. Not every black hole stays neatly fixed at the centre of its galaxy either. When two of them merge into one, the great burst of gravitational waves can carry away more momentum in one direction than in another, and the newly joined black hole is given a slow, silent kick, sometimes gentle, sometimes strong enough to send it drifting away from the galactic centre altogether. Astronomers have found a few of these wandering giants, eased off-centre, coasting through their galaxies like a stone rolled up from the bottom of a bowl. Most of them settle back toward the middle again over long ages, sinking gradually inward as gravity calls them home. But for a time they roam, vast and dark and untethered, carried along by the recoil of their own making. Even the most anchored things in all the universe, it turns out, sometimes wander a while before they come to rest. Given a gentle enough push from their own making, a few of these giants drift off-centre for an age, then sink home again as gravity calls them back. The recoil from a merger can nudge a newborn giant off-centre, setting it adrift through its galaxy before gravity draws it inward once more. There is a natural limit to how fast even these giants can feed, and it gently keeps them from ever running truly wild. As gas falls inward and heats, the light it gives off begins to push outward against the gas still falling in behind it, and at a certain brightness, that outward push of light exactly balances the inward pull of gravity, and the feeding slows itself down. Astronomers call this graceful ceiling the Eddington limit. What it means is that a black hole tends to regulate its own appetite, feed too quickly, and the sheer brilliance of the feeding itself holds the rest of the gas at bay. Built directly into the physics is a kind of natural restraint, a self-imposed calm. These objects are not bottomless drains forever pulling everything down, but careful and measured eaters, slowed by their own light, held gently in check by the very glow they cast outward. Feed too greedily, and the brilliance of the feeding itself pushes the next mouthful away. A built-in restraint that keeps even the giants from ever running wild. That deep self-restraint is part of why the universe is not slowly emptying itself into its own dark centres. For all their fearsome reputation, black holes consume only the tiniest fraction of the matter in any galaxy. The overwhelming majority of stars and gas simply orbit the centre peacefully, age after age after age, never coming anywhere near the edge at all. Our own galaxy has lost almost nothing whatsoever to its central black hole across the entire history of the Earth. The stars wheel on in their long, safe, faithful circles. The gas drifts in its great unhurried tides, and the dark heart at the centre takes only the smallest occasional sip from the very edge of an enormous feast. The galaxy is not being devoured, and never was. It is simply, endlessly, peacefully turning around a centre content to let nearly all of it pass by. The galaxy is not a thing being drained, but a thing being held, nearly all of it sweeping safely past the centre, age upon age, never coming near. Almost nothing ever drops in. A thing would have to lose nearly all its sideways motion and thread itself straight onto a minuscule mark, which scarcely ever occurs. Once in a great while, a single star wanders too near one of these centres, and the galaxy briefly lights a candle in the dark. If a star drifts close enough, the difference in pull between its near side and its far side stretches it gently outward, and a portion of its gas is drawn into a bright swirling ribbon around the black hole, flaring for a season before it slowly fades. Astronomers call such a moment a tidal disruption, and from clear across the universe it appears only as a soft new brightening in a distant galaxy's heart, glowing for some months and then dimming away again. These are rare beyond rare. Any given black hole might see one only once in tens of thousands of years, and they unfold so very far off that they reach us as nothing more than a faint slow flare in the dye. A single star's quiet undoing, witnessed gently from impossibly far away as a distant gleam. Such a flare might visit a given black hole just once in many thousands of years, a single brief candle lit and then released into the long dark. Those rare flares have quietly become a gift to astronomers because they reveal black holes that would otherwise stay perfectly and completely hidden. A quiet black hole, one that is not feeding, gives off no light at all. It can sit at the very centre of a galaxy entirely unseen, betraying nothing. But when a wandering star brightens its surroundings for a season, the flash suddenly announces the dark giant's presence and even hints, by its shape, at the giant's mass. So the universe occasionally lifts the veil on one of its hidden centres, lighting it briefly from within, the way a single struck spark can reveal the shape of an entirely darkened room before fading. Most of the time, these objects keep their long silence faithfully. Now and then, one of them is caught for a moment in a flash of soft illumination, and astronomers learn, with quiet delight, that it had been resting there all along. A spark in a darkened room reveals the furniture for an instant. Just so, a single flare can light up a hidden giant that gave off no glow before. Black holes are often imagined as truly eternal things, but they are not quite. They fade across spans of time so vast that the word eternal almost fits them anyway. A physicist named Stephen Hawking showed that black holes very faintly glow, releasing the barest whisper of energy at their edges, so faint that for the supermassive ones it is very nearly nothing at all. Across enormous stretches of time, this thin trickle of radiation carries away a little of their mass, and the black hole very gradually shrinks. For a giant of billions of suns, the process is so unhurried that it would take a length of time beyond all imagining, vastly, almost meaninglessly longer than the entire present age of the universe, for it to fade away to nothing. They are, in effect, the most enduring objects the cosmos will ever make, the last to leave the stage. The faint glow they release is so slight that fading away would take spans of time, beside which the present age of the universe is the merest opening note. Sit gently with that span of time for a moment, because it is a strangely comforting one to hold. Long after the very last star has burned itself out, long after the galaxies have all gone dark and cold and silent, these black holes will still be here, glowing almost imperceptibly, the final faint lanterns in a slowly emptying universe. They will outlast everything that ever was, every sun, every world, every last trace of warmth and light, fading so unimaginably gradually that, against the full span of their lifetimes, the entire age of stars is only a brief opening scene. There is a deep and surprising peace in knowing that something so steady will keep its long, patient vigil in the dark for so unthinkably long after all the rest has gone to rest. The universe ends, if it ends at all, in the quiet company of these. When the last star has cooled and the galaxies have gone dark, these will remain, glimmering almost imperceptibly the final embers of a long, long night. Across spans of years beyond all naming, even these will thin away, but so unimaginably late that the whole age of stars is only a brief first chapter beside it. The very centre of our own galaxy, all around Sagittarius A star, is not empty at all but richly, almost impossibly crowded. A dense swarm of stars packed far more tightly together than anywhere out near the sun. Within just a few light years of the black hole, millions of stars are gathered into what astronomers call the nuclear star cluster, one of the densest knots of stars in the entire Milky Way. If you could somehow stand on a world there and look up, the night would blaze with countless suns, the whole sky thick with their light from horizon to horizon, never truly dark. And at the very middle of all that brilliant jostling throng sits the dark centre itself, quiet and unhurried, holding the entire shining crowd in its gentle grip. The most crowded room in all the galaxy, and at the exact heart of it, a single point of perfect, untroubled stillness. Stand on a world there, and the sky would never truly darken, blazing with the close-packed light of a million suns crowded around one silent centre. Few places in the whole galaxy pack their stars so tightly, a throng so crowded that the sky there would blaze from edge to edge and never fall fully dark. The stars woven through that dense central knot race along at hundreds of kilometres a second, swept up in the deep gravity at the galaxy's core. Long ago, our own galaxy's centre may have been far more active than the deep calm it keeps today. Stretching enormously above and below the Milky Way's heart are two great bubbles of faint, hot gas, each one reaching tens of thousands of light years out into space, great glowing lobes that were most likely blown outward by a single great eruption from the central black hole millions of years ago, the last time it fed heavily. Astronomers call them the Fermi bubbles, and they hang there still, the slowly cooling echo of that ancient outburst, like wide rings spreading on the surface of a pond long after the stone that made them has sunk from sight. Our quiet centre was not always so quiet, but the storm is very long past now, and what remains of it is only the gentle afterglow, drifting outward, fading into the surrounding dark. Those vast soft lobes of gas still hang above and below the galaxy's heart, the slowly cooling memory of a fire that burned out long before anyone looked up. Two enormous lobes of hot gas still tower tens of thousands of light years out from the galactic core, the fading memory of an eruption ages gone. What our galaxy's heart keeps now in our own age is a profound and deeply settled calm. The great eruption that once blew those vast bubbles faded long before any human being ever looked up to wonder. The central black hole has fallen back into its long quiescence, sipping only the very thinnest trickle of gas that drifts its way. The crowded stars wheel peacefully around it, the bubbles cool and spread and thin, and the whole immense centre wheels in a deep and unhurried order. Were you somehow able to drift there now and look around, you would find not chaos or violence, but a stately ancient stillness, a place that has already done its great work in ages past, and now simply rests, holding its bright swarm of suns in the dark, age after age after age, asking nothing of anyone, expecting nothing, only turning. Its fiercest days are long behind it, and now it keeps a deep and settled calm at the heart of its crowd of suns, holding them, harming nothing. The great storm that once blew those bubbles faded long before the first human looked up, and what remains is a deep and settled calm. A spinning black hole wraps the very space around it into motion, and folded within that whirl lies one of the most elegant ideas in all of physics. Just outside the horizon of a rotating black hole is a region where space itself is dragged irresistibly around, turning like water near the heart of a slow vortex. Astronomers call this strange zone the ergosphere. Stranger still, it is possible in principle to draw energy out of a spinning black hole from within this region, to leave it carrying more than you brought in, borrowing from the black hole's own vast rotation, which slows by the smallest imaginable measure in return. The physicist Roger Penrose first worked out precisely how it could be done. So these objects are not only takers of energy, in just the right dance they can give energy away, spinning down by a feather's weight to send something outward enriched and faster than it came. A spinning black hole can even be coaxed to give a little of its rotation away, sending something outward richer than it came, the giant slowing by a feather's breadth. That same whirl of dragged space shapes the brilliant jets and steadies the swirling disk, and it means a black hole is never truly a still thing, even at its calmest. Even the most quiescent of them turns, winding the nearby dark around itself, a great dark top spinning silently in place for billions of years on end, without ever once tiring or slowing. The motion is utterly soundless and utterly smooth, far too gradual for any eye to ever catch, and yet it threads quietly through everything the black hole does, the precise aim of its jets, the lopsided shape of its glow, the long slow drifting of the orbits nearby. To picture one of these truly is to picture not a frozen pit at all, but a great and unhurried rotation, an endless quiet turning at the very centre of the wheeling stars, smooth as poured honey, old as the galaxy itself. Even at its calmest, it is never quite still, winding the nearby dark around as it turns, a great silent top that has spun since the galaxy was young. The energy these objects can release, when they do choose to feed, is the most efficient in all of nature, more efficient than anything else the universe knows how to do. When matter falls toward a black hole and heats in its swirling disk, a far greater fraction of that matter's mass is converted into pure light than ever happens inside a star, many times more efficient, in fact, than the nuclear fire that warms the sun and lights the day. Gravity, it turns out, is a finer and more powerful engine than even fusion. A single spoonful of matter falling toward one of these centers can release more light than the very same spoonful could ever yield by burning. It is the universe's most powerful means of turning plain substance into pure radiance, and it happens not through any violence we would recognize as such, but simply, quietly, by letting things fall. A mere mouthful of matter falling inward can release more light than fire could ever wring from it, gravity proving the finer engine of the two. A far greater share of matter's mass turns into pure light here than inside any star, making this the most efficient furnace the universe knows how to build. Far in the deep future, our own galaxy and its great neighbour Andromeda will drift slowly together and merge, and in the long fullness of that meeting, their two central black holes will one day join into one. This will not happen for billions of years yet, long past the lifetime of the Sun as we now know it, and when it does, it will unfold across hundreds of millions of years, an encounter so gradual that any creature alive to witness it would feel nothing whatsoever change from one age to the next. The two black holes will sink toward the centre of the newly merged galaxy, circle one another across great spans of time, and finally become a single greater heart at the middle of a single greater galaxy. It is a collision with no crash anywhere in it, a meeting written entirely in the patient language of gravity, and it is, even now, already on its way toward us. Across the whole of the universe, these dark centres tend to gather precisely where matter itself is densest, at the bright knots and crossings of an immense structure that astronomers call the cosmic web. Galaxies are not scattered evenly through space at all. They string themselves out along enormous shining filaments, like beads of dew gathered along the threads of a spider's silk, with great, dark, empty voids opening between them. And at the densest junctions of that web, where many galaxies cluster close together, the very largest black holes are found, anchoring the richest gatherings of light in the cosmos. The universe is threaded through everywhere with this hidden architecture, and the giants sit at its brightest intersections, like steady lanterns hung at the crossroads of an enormous, invisible, slowly evolving lattice of light and dark. The giants gather at the bright crossings of that hidden web, like lanterns hung where the threads of the cosmos meet, anchoring the richest gatherings of galaxies. The same gravity that builds these great centres also built you, in a roundabout and rather lovely way. The very stars whose deaths concede black holes are the same stars that forged, deep in their cores, the carbon and the oxygen and the iron now woven all through every living thing on Earth. The cosmos that makes dark centres also makes the very stuff of bodies and breath, from the same patient gathering of matter under the same unchanging pull of gravity. You're not separate from this long story of collapsing gas and wheeling stars at all. You're one of its later and gentler chapters, made of atoms cooked long ago in stellar fire, resting now beneath a sky full of the very engines that drive the whole of it. The hand resting on the blanket and the heart of the distant galaxy are, in the deepest sense, close kin, shaped together by one single set of laws. The atoms in your hand were forged in the same kind of stars whose deaths concede black holes, so the resting body and the galaxy's heart share a single ancestry. Picture, just for the simple comfort of it, a single world that orbits one of these giants from a safe and easy distance. A calm planet circling far out around a supermassive black hole, much the way the Earth circles its sun. It would be perfectly, completely stable. The planet would trace its long, patient path year after year, untroubled, held in a steady orbit by the very same gravity that holds any world to any star anywhere. Its sky would simply hold a strange dark centre, where ours holds a bright one, perhaps faintly ringed in a soft distant glow, perhaps utterly and beautifully black against the surrounding stars. There is nothing whatsoever about a black hole that forbids such a thing, or makes it dangerous. From a comfortable remove, it is just another centre to circle, every bit as safe to orbit as the sun that warms your own days, only darker and far more still and far more silent. A planet could circle one as safely as the Earth circles the sun, tracing its quiet year beneath a sky that holds a dark centre instead of a bright one. The darkness at the heart of these objects is not really an absence at all, but a place, and that one quiet distinction softens the whole idea of them. We tend to think of black as nothing, as pure emptiness, as the void where things have ceased to be, but a black hole is intensely something, a region where space and time themselves are folded so deeply that they take on a shape entirely their own. It is full, in its own strange way, the most concentrated thing the entire universe knows how to make. The blackness we see is not a hole torn in reality, but reality itself bent so far over that no light can ever climb back out to tell us of it. There is a quiet dignity in that, once you feel it, not an emptiness to fear in the dark, but a fullness too deep for light, a darkness that is, in truth, the single most substantial place there is. The black we see is not a gap in things, but the fullest thing of all, reality folded so deep that no light can climb back out to speak of it. Whether a galaxy still makes bright new stars or has gone calm and golden often comes down, in the end, to the patient work of its central black hole. The very grandest galaxies, those vast elliptical clouds of older, redder stars, have largely stopped forming new suns altogether, their gas long since heated and stilled by the energy pouring from their central engines. They glow now only with the warm amber light of aging stars, beautiful and deeply settled, all their star-making days behind them. Smaller spirals like our own still spin off fresh blue stars along their turning arms, lit and lively and young. The colour and the whole character of an entire galaxy, youthful and blue or mature and golden, is shaped, in real part, by the long, unhurried governance of the dark heart resting at its centre. The black hole helps to decide, across the ages, what colour its galaxy will finally wear. A galaxy's whole complexion, youthful blue or aged gold, is decided in part by the long governance of the dark engine at its core. To truly hold the size of the greatest horizons, it helps to walk the distance out in steps. The event horizon of the largest known black holes spans hundreds of times the distance from the Earth to the Sun, a width across which sunlight, which reaches us here in a mere 8 minutes, would travel for many days on end without ever arriving at the far edge. And yet all that immense breadth surrounds an object that gives off no light, makes no sound, and sits so unimaginably far away that its existence touches nothing you will ever feel in your life. It is pure scale, pure stillness, a great dark sphere hanging silent in the deep between the galaxies. The mind cannot quite hold it, and the lovely thing is that it does not need to. It is enough tonight to simply let the bigness wash gently over you and pass on by like weather. The mind cannot truly hold a size like that, and the kindest thing is that it need not try, only let the bigness move through and drift away. When you look upon the light of a distant quasar, you are truly looking at a kind of time capsule, sealed long ago and sent across the ages to find you. That light left its blazing source billions of years ago, in an age when the universe was young and the Earth itself did not yet exist anywhere, and it has been crossing the empty dark the entire time to arrive, at last, in a telescope tonight. To see a quasar at all is to see the deep past directly, not a picture or a recording of it, but the very light itself still carrying its news of a black hole as it was before the sun was ever born. The farther these beacons lie from us, the older the story they faithfully tell. The whole night sky, seen this way, is a vast, quiet archive of ancient light, and the distant quasars are among its very oldest, most far-flung pages. To watch a quasar shine is to read a page of the deep past directly, the light itself, older than the sun, still faithfully carrying its ancient news. The farther a beacon lies, the older the story its light tells, so the whole sky doubles as an archive of the deep past. There was an era, long ago, when the universe grew its stars and fed its black holes more furiously than at any time before or since. Astronomers sometimes call it the cosmic noon. Some 10 billion years back, galaxies brimmed and overflowed with cold gas. New stars blazed into being at a tremendous rate all across the sky, and the central black holes feasted and shone as brilliant quasars throughout the young cosmos. The universe was at its very brightest and most fertile then, a kind of high noon of all creation. Since that distant peak, the great gathering has slowly eased, the gas has thinned, the star-making has quieted, and the quasars have mostly dimmed to silence. We live now in the long golden afternoon of the universe, well after its most brilliant hour, settling gently toward a quiet evening that lies still far ahead. The fertile high noon of the cosmos is long behind us. We live in its golden afternoon now, the great beacons dimmed, the pace of creation gently easing. Perhaps the most reassuring thing about all of this, in the end, is simply that the same laws hold everywhere, without exception. The very gravity that shapes a supermassive black hole 26,000 light-years away is precisely the same gravity that holds you to your bed tonight. Not a different force, not some stranger physics reserved for the deep cosmos, but the very same law, written at every scale at once. The equations that describe the bending of light around distant M87 are the identical equations that describe the gentle arc of a stone tossed across a yard. The universe does not keep one set of rules for the vast and another for the small and near. It is all one seamless fabric, unbroken from the heart of a galaxy to the weight of a hand resting on a quilt, and that deep wholeness is, in its own way, a profound and steadying comfort to carry into sleep. One law, unbroken, runs from the bending of light around a distant giant to the gentle weight that holds you against the bed tonight. The arc of a tossed stone and the bending of starlight around a far-off giant answer to one and the same rule, holding true from the hand to the heart of a galaxy. The masses of these black holes form a smooth and continuous range, running from the merely large all the way to the very nearly unthinkable. There is no single size the universe seems to prefer. Across the galaxies, astronomers find them at millions of suns, at tens of millions, at hundreds of millions, and on up steadily into the many billions, spread along an unbroken scale like notes, running the full length of a great keyboard. Each galaxy carries the size that matches its own long history of growth and merging. Some of them are modest and quiet, some are vast almost beyond easy telling, and every single one of them sits at its own centre, holding its own galaxy, a lone dark anchor scaled exactly to the great wheel it patiently keeps. The universe makes them in every magnitude there is, and finds a fitting place for each and every one, somewhere out in the turning dark. From a few 100,000 suns to many tens of billions, they fill an unbroken scale, each galaxy fitted with a centre scaled to its own long story. Even surprisingly small galaxies sometimes harbour one of these dark centres within them. Astronomers have found supermassive black holes tucked inside dwarf galaxies, faint, compact little gatherings of stars far smaller than our own Milky Way, each one carrying a dark heart heavier than anyone had ever expected such a modest galaxy to hold. These quiet discoveries hint that the black holes may, in some cases, have come first, or grown up right alongside even the very smallest galaxies from the beginning. It suggests these centres are not a luxury reserved for grand galaxies alone, but a nearly universal feature of the cosmos, seeded early and widely, tucked even into the little island clouds of stars scattered all through the cosmic dark. The pattern, it seems, runs far deeper and far wider than the great galaxies alone would ever have told us. They are nearly everywhere. Even faint dwarf galaxies, far smaller than our own, have been found to cradle dark hearts, heavier than anyone expected such modest places to hold. These finds hint that the dark centres may have come first, seeded early and everywhere, tucked even into the smallest island clouds of stars in the cosmic dark. Surrounding every galaxy is a vast, completely invisible halo of dark matter, far larger and far heavier than all of its stars put together, and the central black hole seems somehow tied to that hidden cocoon as well. The weight of the black hole appears to track not only the bright bulge of stars at the core, but, in subtler and stranger ways, the enormous unseen mass that envelops the whole galaxy from edge to edge. It is as though the dark centre keeps a kind of faith with everything around it, the visible and the invisible alike, growing in even proportion to the entire structure it anchors and steadies. Layer upon patient layer, from the swarming inner stars to the unseen outer halo, the galaxy holds itself together in balanced relation, with the black hole resting calm and central at the still heart of all of it, keeping the whole arrangement in tune. The black hole seems to keep faith even with the vast invisible halo of dark matter around the galaxy, growing in even proportion to the whole. The glow around our own central black hole is not steady at all, but softly flickering, brightening and dimming gently from one hour to the next as small wisps of gas swirl and heat near the edge. Astronomers patiently watching Sagittarius A star see it shimmer faintly, a restless little light that rises and fades much like the slow breathing of a settling ember in a hearth. Nothing dramatic ever disturbs it, only the constant, delicate stirring of the thin gas that happens to drift nearby, warming briefly as it circles and then cooling again. The heart of our galaxy is not a frozen, lifeless thing, but a living glow, pulsing almost imperceptibly, keeping its own faint and patient rhythm at the very centre of the wheeling dark. It breathes, in its way, slowly, softly, endlessly, and has been breathing so since long before the Earth first formed. Our own centre shimmers faintly hour by hour as thin wisps of gas warm and circle, a soft, restless pulse, the slow breathing of a settled ember. When astronomers first imaged the giant in M87, they soon went a step further and mapped the magnetic fields threading through the light around it, revealing them woven into the swirl of the glow. The bright ring, they discovered, is laced everywhere with powerful magnetic lines, spiralling gracefully around the central darkness and helping to launch that great jet which streams thousands of light years outward. The image of those fields showed the light combed into sweeping, elegant arcs, very much like iron filings arranging themselves around an unseen magnet, or the soft spiral of cream stirred just once into a cup of coffee. The forces shaping these centres, it turns out, are not chaos at all, but a kind of deep order, magnetic threads winding the glowing gas into elegant patterns, guiding the great outflow with an almost deliberate, unhurried grace. Even here, at the edge of the most extreme objects there are, the universe keeps its quiet order. You are at this very moment in a perfectly stable orbit around one of these objects, and you have been every single second of your life so far. The Sun, faithfully carrying the Earth and you along with it, circles the galactic centre once every 200 and some million years, held in that immense long path partly by the central black hole and partly by the great combined mass of all the galaxy's 100 billion stars. You have already travelled an enormous arc of that immense circle since the day you were born, and you have felt absolutely nothing, no wind, no motion, no faint sense of speed at all, even as you sweep through space at well over 100 miles every single second. The most enormous journey of your entire life is the one you cannot feel in the slightest, a wide, smooth, silent circle around a distant and gentle centre, carrying you softly through the dark. You ride that immense circle at a speed beyond all sensing and feel nothing whatsoever, only the deep stillness of your own quiet room. For all of their fearsome reputation as great cosmic drains, it is astonishingly rare for anything at all to actually fall into one of these centres. The space immediately around a black hole is overwhelmingly empty, and matter travelling on a circling path tends simply to stay on that path, just exactly as the Earth does not spiral down into the Sun but circles it safely forever. To truly fall in, something must first lose almost all of its orbital motion and then aim itself nearly straight at the tiny central target, a rare and unlikely alignment indeed. So the gas and the stars near these centres overwhelmingly swing past and continue serenely on their way, age after age after age, entirely untouched. The black hole waits at the focus of countless orbits, and very nearly everything that ever comes near it simply rounds the long turn and sails onward, just as it always has and always will. To truly fall in, a thing must shed nearly all its motion and aim straight for a tiny target, so almost everything that nears simply rounds the turn and sails on. The light from the gas around these centres carries an echo of the black hole's deep pull, written subtly into its very colours. Light climbing out of such powerful gravity is stretched gently toward redder shades, and the gas whirling at tremendous speed shifts in colour too, as it sweeps first toward us and then away, so that by carefully reading the precise tints of that glow, astronomers can trace both the motion and the depth of the gravity well with remarkable care and patience. The light itself becomes a kind of fingerprint, quietly encoding the speed of the great swirl and the weight of the hidden centre, all at once, all together. Everything a black hole does, it turns out, it signs in the colour of the light around it, and patient, careful eyes, here on this small world, have slowly learned how to read that delicate signature from clear across the entire universe. Whatever it does leaves a mark on the glow nearby, a faint colouring that careful instruments here on Earth have learned to read from unimaginable distance. Sometimes two galaxies caught in the long, slow act of merging each still carry a brightly feeding black hole, and the sky shows us a rare pair of quasars blazing side by side. Astronomers have found these double beacons, two brilliant centres shining within a single merging system, drawing gradually toward one another across the ages, on their patient way to one day becoming one. They're a kind of snapshot of the great merging process, caught partway through its unfolding, two bright hearts that will, in some far distant epoch, finally join into a single greater one. To find such a pair at all is to glimpse directly the future of every galactic centre there is. Not endless solitude in the dark, but the occasional grand and gentle convergence, two distant lights slowly becoming a single one in the long, patient turning of cosmic time. Now and then the sky shows two quasars blazing side by side in a single merging system, a glimpse of two bright hearts on their long way to becoming one. In one such pair, known as OJ-287, a black hole of some 100 million suns swings around a giant of many billions, plunging through its companion's bright disk roughly every 12 years, and setting off a double flare seen across 3.5 billion light-years. The name itself, black hole, is younger than many of the people who will ever hear these words, and it arrived almost entirely by chance. For decades these objects went along without any tidy name at all, called collapsed stars or frozen stars, or longer and far clumsier things, until the simple phrase black hole came into common use near the end of the 1960s, often credited to the physicist John Wheeler, who helped the words finally stick. It is admittedly a curious name for an object that is neither truly a hole in anything nor, when it is feeding, even black to the eye. But it caught the human imagination as no dry technical phrase ever could have, and it has held its firm place in the language ever since. Two plain and simple words for the single most extraordinary kind of object the entire universe contains, settling into our speech as softly as the things themselves sink into the dark. Two plain words, black hole, for the most extraordinary object the universe makes, a name that arrived almost by accident and would not leave. Consider for a moment how thoroughly these centres have stayed hidden through nearly all of human history. For every single generation that ever looked up at the night, every shepherd, every sailor, every wandering child tracing the shapes of the stars, the dark heart of the galaxy was there, exactly where it rests now, quietly holding the whole sky together, and not one of them ever knew. It was found only within a single recent human lifetime, after many thousands of years of watching of the heavens. The most important object in our entire galaxy stayed perfectly, completely invisible until almost yesterday, and the night sky looked whole and complete and beautiful all the same. There is something genuinely humbling and deeply kind in that the universe holds its vastest wonders so faithfully, asking nothing of us until the very moment we're finally ready to notice them. For every generation that ever looked up, the dark heart of the galaxy was already there, unseen, and only within a single recent lifetime did anyone finally find it. For every shepherd and sailor and wandering child who ever looked up, that dark heart was already there, exactly so, and none of them ever knew. These objects unite the two greatest theories in all of physics, and in doing so they mark the very frontier of what is presently known. The bending of space around them is described beautifully by the theory of gravity. The faint glow that Stephen Hawking predicted at their edges arises instead from the physics of the very smallest things. At the centre, where those two great descriptions must somehow finally meet and agree, our understanding simply runs out. And so these centres are exactly where physicists go to seek the deeper law that would at last join the cosmos of the immense to the cosmos of the tiny. They are not only ancient anchors of galaxies then, but also signposts pointing on toward the next great understanding, quietly marking out there in the dark the present edge of the whole human map of reality. Where gravity and the physics of the very small must somehow meet, our understanding still runs out, and these centres mark that frontier in the dark. Where the law of gravity and the law of the very small must somehow meet and agree, our understanding still runs out, and these objects sit at the edge of the map. The shadows in those famous images are as close to seeing pure gravity itself as the universe will ever allow us to come. There is nothing material whatsoever in a black hole's silhouette. No surface, no substance, no object at all, only the shape that space itself takes when mass has gathered past every ordinary limit. To look upon the dark circle in the picture of M87 is to look upon the bending of reality directly, rendered briefly visible only by the warm ring of light wrapped around it. It is perhaps the single most abstract thing that has ever been photographed, and yet there it plainly is, a real image of a real place, caught by a telescope the size of the whole turning world. Pure geometry, the bare shape of gravity, made briefly visible to human eyes for the first time and then let go again. There is no surface in that silhouette, no substance at all, only the bare shape space takes when mass gathers past every limit. Pure geometry made briefly visible. Astronomers now believe that these dark centres played a real and guiding hand in how the galaxies came to look the way they do. By heating and stirring the gas, by launching their great jets and winds, by gently quieting the making of new stars at just the right moments across cosmic time, the central black holes help to sculpt the very galaxies that house them, shaping their sizes, their colours, and the long, slow arc of their growth. The galaxy we ourselves live in, with its graceful spiral arms and its gentle ongoing star-making, quietly wears the marks of its central engine's long and patient governance. The heart did not merely sit passively within the body, it turns out. In slow and subtle ways, across billions upon billions of years, it helped to decide the body's very shape. The centre and the whole grew into themselves together, hand in hand. By heating gas and launching winds at just the right times, the dark centre helped sculpt the very galaxy that holds it, shaping its size and colour across the ages. There is a beautiful and unexpected symmetry in the fact that the most extreme objects in the entire universe are also among the very simplest to describe. A star is a churning, endlessly complicated thing. Layered fire, restless currents of gas, a whole turbulent burning life from birth to death. A black hole, by quiet contrast, can be captured almost completely in just a few clean numbers. The universe, strangely, seems to grow simpler rather than ever more complicated at its very deepest extremes, as though some great simplicity were patiently waiting on the far side of the greatest intensity. The most concentrated objects that reality knows how to make are also the most elegant of all, the most utterly stripped of every detail. A perfect smoothness arrived at only by first passing through the most absolute conditions there are. Out of the utmost extreme, the utmost calm. A churning, complicated star ends as a thing of perfect smoothness, the deepest objects in nature also the simplest the language can describe. A churning, layered, burning star ends its life as a thing of flawless evenness, the most extreme objects in nature turning out to be the tidiest to write down. Each of these centres is older than nearly everything around it, a kind of silent elder resting at the very heart of its galaxy. The black hole at the Milky Way's core was very likely already there before most of the stars now wheeling around it had even formed, seeded in the galaxy's earliest days and growing as the galaxy itself grew up around it. It has watched whole generations of stars ignite, burn, age, and fade away, holding its own place steadily through all of it, the one truly constant presence while everything else came and went and came again. To rest beneath such a sky tonight is to rest beneath something genuinely, almost unimaginably ancient. A steady dark centre that was already old when the sun itself was new, and that will still be old, and still be there, long after the sun is finally gone. It was already ancient when the sun was new, and will be ancient still when the sun has faded. The one steady presence while generations of stars come and go. It was already ancient when the sun first kindled, and it will still be here, turning in the dark, long after the sun has burned away. Think too of how very much these distant objects have given us, simply by existing to be studied. From the long effort to understand them, we have learned how gravity bends the path of light, how space itself can be dragged into motion, how galaxies are born and shaped and steadied over the ages, how the whole universe softly hums with waves far too slow for any ear. Objects that touch us not at all, across distances utterly beyond all feeling, have widened the human mind more than almost anything else in the entire sky. They ask nothing whatsoever of us, threaten us with nothing, demand nothing in return, and yet simply by being there and being studied, they have taught us a great share of all we now know about the cosmos. The most distant things of all have somehow brought us the very nearest to understanding. Things so utterly remote beyond every reach and every feeling have taught us more about the deep shape of reality than almost anything else above. They ask nothing of us and threaten nothing, and still, merely by being there to be studied, they have stretched human understanding further than almost any other thing overhead. For all of their tremendous power, these centres spend very nearly the whole of their existence doing almost nothing at all. The dramatic feeding, the brilliant quasar light, the great streaming jets, these are only brief and occasional episodes in lives that are otherwise spent in deep, dormant, untroubled quiet. The overwhelming majority of supermassive black holes in the present-day universe are exactly like our own, still, dark, sipping only the very faintest trickle of gas, holding their galaxies in long calm. Their natural and ordinary state is rest. The fireworks are only the rare exception. The long deep stillness is the unbroken rule. They are by and large the stillest and most peaceful residents of the entire cosmos, resting at the centres of the wheeling stars, doing nothing, needing nothing, for ages longer than the mind can hold. They simply abide. The brilliant feeding and the great jets are only rare, brief episodes. The natural state of nearly every one of these giants is long, dormant, untroubled quiet. The darkness of a black hole is, in the very end, the deepest kind of stillness the whole universe contains. No light ever stirs within it. No sound, no signal, no motion of any kind ever escapes its quiet edge. It is the most perfect quiet there is anywhere. Not an emptiness at all, but a completeness so total that nothing can ever leave it to disturb the calm. In a vast cosmos full of churning stars and streaming light and restless, endless motion, here is one place of absolute repose, sealed and serene, faithfully holding its silence at the very heart of every galaxy that turns. There is something deeply and genuinely restful in simply knowing that such places exist at all. Vast hidden reservoirs of pure stillness, scattered all through the dark, each one keeping its own perfect, untroubled calm, age after age after age, asking for nothing. In a cosmos of restless churning motion, here is a single haven of perfect stillness, sealed away at the heart of every turning galaxy. In all the restless motion of the cosmos, here is one perfect stillness, sealed off and unbroken, kept at the core of each great wheel of stars. And these silent dark centers will, in the end, be the very last things the universe holds on to. When the stars have all burned low and gone out, when the galaxies have drifted apart and faded into darkness, when the long evening of the cosmos deepens slowly toward its final night, the black holes will still remain, fading so unimaginably gradually that they outlast all the rest by spans of time beyond every counting. They are the universe's final keepsakes, its most enduring forms of all, glowing almost imperceptibly in an emptying dark for an unthinkable length of years. The cosmos began long ago in brilliance and fire, and it will close, if it closes at all, in the company of these, the last calm anchors, keeping their long, faithful watch in the dark, long after every other light has gone to its rest. These will be the universe's final keepsakes, glimmering faintly in an emptying dark for spans of years beyond all counting, the last calm anchors of all. Long after the final star has burned away and the galaxies have scattered into the dark, these will still be here, the universe's last enduring keepsakes, and here, at the very end, is the gentlest thought of all to rest upon. Far above you tonight, at the still hub of the slow-turning wheel of the Milky Way, that ancient dark heart is turning, exactly as it has turned through every single night of your life and every night before you were ever born. It holds 100 billion stars in their long and faithful circles, and it holds them not by reaching or grasping or devouring anything, but simply, only, by being there. A steady, quiet weight at the centre, around which the whole of everything turns in deep and lasting peace. It asks nothing of you. It has never once asked anything of anyone in all its long ages. It only holds, the way the very deepest things hold, quietly and patiently and without any end at all. And you are held too tonight, in your own small and gentle orbit, carried along on that same vast and turning wheel, exactly where you're meant to be, exactly where it is safe to rest. You have drifted out to the far quiet edges of the universe tonight and come gently back again, and there is nothing left to do now but rest. Nothing here was ever meant to be kept or carried. Let the facts go now, every one of them, the great masses, the rings of warm light, the distant blazing beacons, the slow turning of the dark. They have done their gentle work, carrying your mind softly out among the calm centres of the galaxies, and home again, and now they can drift away like morning mist off a still pond, leaving only quiet behind them, and ease, and the weight of your own resting body. And if you are still here, drifting at the soft edge of sleep, another of these gentle journeys is already waiting there on the screen for you, there whenever you might wish for it, or never at all, asking nothing of you tonight. There is nothing more to reach for now, and nowhere you need to be. The whole vast sky will keep on turning without your watching over it, just as it has through every night before and every night to come. You do not need to remember any of it. Not the names, not the numbers, not a single one of the distant lights. They were only company for a little while, soft company in the dark, and they have served their whole purpose if they carried you here, gently, to this soft and settled place at the quiet end of the night. Let your breath grow slow and even now. Let the weight of the whole long day sink down through you and away into the dark. The mind can stop its wandering at last. There is nowhere left to go and nothing left at all to hold on to. Far overhead the great dark centre turns and holds its 100 billion stars and keeps its perfect silence. And here, so very much closer, you are held too, warm and safe and still, carried gently on the very same slow wheel. Let your eyes stay closed. Let the dark be soft and kind around you. Let everything that was ever bright grow dim and easy and quiet now. Rest. And now, 101 wonders are resting with you. Sleep now. Good night.